Hello, Math Studies students, and welcome to your online lesson. Today we'll be learning to apply a combination of formulas to find the area of two-dimensional figures. Our overall learning intention is to find the area of combined figures. And what I mean by combined figures is where we take multiple polygons and put them together to create a new shape or figure. We will know we are successful when we can efficiently find the area of combined two-dimensional figures. So for most of these problems, we'll be using multiple formulas, breaking up the big figure into multiple little shapes that we're already familiar with. Here's a quick review on our basic polygon and circle area formulas. For a triangle, it's 1/2 base times height. The thing to remember here is that the height must be perpendicular to the base. On a right triangle, sometimes that's both of its legs, but otherwise we need to make sure the height is perpendicular to whatever base we are using. Parallelogram, same idea, must be perpendicular between the base and the height. Base is often just one of its sides, and the height is the perpendicular distance to the other side or its opposite side. Remember, rectangles and squares are also parallelograms, but those have a right angle built into the shape, so you can just use two perpendicular sides for the base times height. For a trapezium, also known as a trapezoid, we are averaging our two bases, represented as A and B in this formula. You add them together and divide by 2, or multiply by half, and then we again multiply by that perpendicular height. And finally, for a circle, we're doing pi r squared, or pi times the value of our radius times itself. For our first example, we're going to find the area of the following. This one kind of looks like a house that's been tipped off to its side, or some sort of arrow-shaped figure. It's clearly made out of a rectangle and a triangle. So let's start off with the rectangle part. If I draw this little vertical line here, we can see the rectangle. The width of that, also known as its base, would be 5.3. Now you might look at the bottom of this and say, no, there's an 8.6 labeled there. However, this 8.6 extends all the way from this edge to the tip of the triangle, which includes both figures, and we don't want both figures, we just want the rectangle to start with. So I'm going to use the 5.3, and then the height would be 3.2. I write down my area formula, which is base times height. So my base again is 5.3 times 3.2. All right, and I'm going to throw that into a calculator, and I end up with 16.96. Now you might say that's 4 significant figures. Do we need to round that? Well, since this is exact, I did not round it all, and I'm going to leave it that way. Also, it's not the end of the problem, so I don't want to round early, even if I needed to, which I won't on this problem. All right, so now we've got our triangle. Triangle is 1/2 base times height. You might say there is no base to this triangle, but again, base is not about its location. It doesn't have to be at the bottom of the picture. In fact, triangle has 3 sides, and any one of those sides can be the base. The important thing is that we know the height that's perpendicular. Well, I don't really know anything about this side that I just traced here in red. I'll trace another side in blue, and I don't know anything about that one. Maybe they're the same, maybe they aren't, but I don't know anything about those. The one that I originally covered up, which I'll do now in green here, that one I'm going to treat as its base. And the reason for that, number one, I know its length. It's the opposite side of this rectangle, and so that should have a base of 3.2. What I need now is that perpendicular height that extends up here, has to be perpendicular, and that distance I can find. Since I know this overall distance here, I can take this 8.6 and subtract the part that we knew of the rectangle over here, this 5.3. And I end up with a height of 3.3. So I'm going to do my area formula for a triangle now. So I have area equals 1/2 base times height. And I would have 1/2 times my base, which is going to be the 3.2, and height, which is going to be 3.3. I'll throw that into a calculator, and I get 5.28. So the area of my triangle, 5.28. Now it feels like I'm done. I found the area of the rectangle, found the area of the triangle. But remember, what we're doing on our learning intention here today is finding the area of combined figures. This is combined from a rectangle and a triangle. in order to combine their areas, we need to add them together. So I'm going to take, for my total area, I'm going to have the 16.96, which came from my rectangle. I'll write that in red. Plus the 5.28 that came from my triangle, written here in green. And then my final answer, I'll put together here in blue. And I end up with 22.24. Now, since I'm here at the end, I should put a label on. We were using meters throughout this problem, and since it's area, it needs to be meters squared. Now, that's 4 significant figures, but I didn't round anywhere, so I don't need to round this, and I would advise against it. All right, on to our next problem. This is sort of a classic area problem where we have 2 shapes, and one of them is like a cutout. So we have this rectangular figure, but then there's also this circle that's cut out. I mean, it looks like sort of a bag toss top of a wood panel, or it might be something like a moving part in a machinery where you have this little opening to make a lock or something like that. But one way or another, we have this rectangle, and then there's this little cutout of a circle. So let's start with the rectangle. Area is equal to base times height. I'm always writing the formulas down when I start off these problems, even on simple ones like base times height, because there's other simple formulas like 1/2 base times height where I don't want to forget anything that's important, like the 1/2 or something like that if we were dealing with a triangle. So I'm going to have 7.8 as my base, and then I have my height 4.5. Now, there's only one other number here, and that's clearly in reference to the circle, so I'm going to ignore that one for now. When I multiply those together, I end up 35.1 as my final area of that rectangle. Now we've got this circle. I'll do these computations in blue. For our circle area, we have pi r squared. Now, how did I know immediately to go to the area formula? We're finding area, so I don't need to work with circumference or anything like that. Now, what's actually given here? They have 2.1, and you can see that it's extending from one end of the circle all the way to the other end. What do you call a line segment that extends all the way from one to the other? That would be our diameter. However, diameter is not what's in our formula. We have r, or our radius. So to find our radius from our diameter, we simply take our diameter and divide it by 2, and that would equal our radius. And so since our diameter is equal to 2.1, we can divide that by 2, and we end up with 1.05. So our radius is 1.05, so my area is going to be equal to 1.05 is my radius squared times pi. Now you'll notice I flip-flop the r squared and the pi just because it's good form to put your numbers first and any other symbols or variables towards the end, which is what I've done here. Now I'm going to reach for a calculator and find the value of 1.05 squared. And I end up with 1.1025, and I still didn't put in the pi. So this right here would be my exact answer. No rounding has occurred. And you'll notice there's several decimals, but I don't want to round because I'm trying to leave it exact, and that's why I put pi in my answer. Now, I could round that, but I'm not going to right now. So now let's go back to the original problem. We had this rectangle, and then we had the circle that was cut out. It was no longer there. So I don't want to add this time. It's not like we have a circle that's like being added on as a shape here. It's a circle that's removing some area. Like I wouldn't have to paint that section of this board. So instead of adding, I'm going to subtract. So I'm going to start with the area of my rectangle, which we had in red, which was 35.1. And now I'm going to subtract the area of my circle, which is 1.1025 pi. Now, can I go in my calculator and simply do 35.1 minus 1.1025 and then slap a pi back on at the end? And the answer is no, because this 35.1 does not have any pi's involved, whereas this number, the 1.1025 pi, does. So we'd say they're not like terms, just in the same way that if I had 2 plus 3x, I could not combine those because they're not like terms. I don't know what x is. Because of that, if I want to leave my answer exact, I'm done. I just need to put my label on, and we were dealing with centimeters here, and it's area. So it would be an expression as our answer. If you'd like to put it in parentheses just to let people know that this is all one answer, you can do that. It's not totally necessary. But we have 35.1 minus 1.1025 pi. Now, if I want to just get a rounded value so I have a better idea of the actual numerical quantity of area that I have, just throw it in your calculator, 35.1 minus 1.1025, and then use the pi button on your calculator so that you're not using the rounded value of 3.14, and we end up with approximately 31.6 centimeters squared. 31.6 centimeters squared. Now let's see if this makes sense. Our original rectangle was approximately 35.1 centimeters, or exactly 35.1 centimeters squared, and this is less than that. It's not a ton less, but if we look at the circle, that wasn't a ton of the actual surface area that we had. So a small circle's been removed, and we're not quite 4 units less. Makes sense. All right, moving on to one correction. That actually concludes. So just remember, we're using area as our formulas, all our old area formulas that we've had in the past. We want to decide if we're combining those areas with addition, if there are multiple shapes getting put together like our first example, or if we're doing cutouts or removing sections like we did on our second example, in which case we're going to take our area formulas and then subtract the values. All right, till next time.